Toyota has taken one of the most unexpected steps of all time with its new way of thinking, going against the future vision of the entire automotive industry. Instead of betting on electric cars, Toyota has decided to give internal combustion engines a new lease of life. According to the company's CEO, the new engine will surprise the entire automotive industry. However, this decision did not come out of nowhere, as insisting on keeping its internal combustion engines on the market has been one of Toyota's main goals for some time. The engines and their well-known reliability are what have kept Toyota ahead of the competition, and it is only logical for the company to continue exploring and modernizing these models so that they can maintain this advantage. Toyota has truly outdone itself with the final product of this race. We are talking about a revolution that is bigger than the emergence of hybrids, led once again by Toyota and its Prius. You can imagine the absolute importance that this technology will have. Well, that is exactly what we will see in this video, so stay tuned until the end. What is Toyota's all-new technology? The technology that has been getting a lot of attention and mesmerizing car lovers is Toyota's new hydrogen-powered engines. And no, we're not talking about hydrogen electric vehicles like the Toyota Mirai. What Toyota is developing now is a new hydrogen combustion engine technology. Fuel cell electric vehicles like the Mirai have a bit of a performance problem. And by that, I mean they are much less powerful, much heavier, basically mediocre in terms of everyday usability. Even years after the first units were produced, they are still too impractical to be useful. But what we can't deny is the ecological component that comes with using hydrogen, since it is the most abundant element in the world. And also, we are totally ecological. It is understandable that Toyota wanted and still wants to develop cars that use it, since it is very conducive. This is especially interesting now, at a time when lithium-ion batteries tend to generate a lot of controversy in terms of how environmentally friendly they really are, considering how lithium mining can poison the soil and water around the mines. Furthermore, even with continued development of batteries, the charging process and their range simply leave a lot to be desired. Combining the power of internal combustion engines with the environmentally friendly component of hydrogen would solve all the problems of both technologies. BMW already explored this technology in the late 90s and early 2000s, and it showed a lot of potential. Even back then, when BMW engines switched to hydrogen, such as the E38 and E65 7 series, they were codenamed BMW Hydrogen 7. They were powered by a heavily modified V12 engine and proved to be quite reliable, producing high power without being less fuel efficient than the gasoline version. However, the hydrogen infrastructure at that time was non-existent, which is why neither of these two made it out of the prototype phase. But thanks to Toyota's efforts with the Mirai, the supply chain has expanded considerably since then. As a result, Toyota, unlike BMW, now has a real basis to start making its own hydrogen combustion engine, which is exactly what the company is doing. With all this in mind, it's time to take a look at the details of the hydrogen engine and explain how it compares to internal combustion engines. The biggest similarity between the two technologies is that they both rely on internal combustion. In addition, gasoline tends to make excellent basis for modifications that would allow for adaptation to use hydrogen. Most hydrogen engines are designed this way, especially Toyota's. There are two engines that Toyota currently has in its portfolio, both designed for different purposes. The most popular of the two is the turbocharged 1.6 liter 3-cylinder. Yes, the same one found in the GR Yaris and GR Corolla. The engines are so similar to each other that, despite the change in fuel, the hydrogen 1.6 liter is as loud as its gasoline-powered counterpart. The other engine is Toyota's 5.0 liter V8, which is derived from the same engine used in the Lexus RCF. This engine, unlike the 1.6 liter, which is planned for use in smaller sports cars, is designed as a high-output engine. Toyota plans to use all of this power in its pickup trucks, large pickups, and even some larger sedans. The best part about all of this is that none of these engines lost much power after being converted to hydrogen. Sure, there was a loss, but the difference is negligible to say the least. But in order to achieve these performance numbers without sacrificing fuel economy, Toyota's brand capability required several crucial changes. What modifications were made to make the engine work? Several modifications were made to the 1.6 and 5.0 engines to make them run reliably on hydrogen. First and foremost is the fuel system. Hydrogen is a gas, and to store it, it is pressurized and cooled until it becomes a liquid. This meant that the fuel system needed to be changed to something that could handle high pressures better than the standard system, which is designed for a fuel that remains liquid at room temperature, such as gasoline. These changes include, most notably, a new fuel pump and injectors, as well as fuel tanks that are structurally different from the standard fuel tanks. They are the same as those used in the Toyota Mirai, which means they are quite large, like LPG gas tanks. The ignition system was also changed to a different solution, using special spark plugs that ignite hydrogen more efficiently than the traditional spark ignition system. In addition, the electronic control system also needed to be replaced to optimize performance and fuel efficiency, allowing the engine to be utilized much better and significantly increasing its durability. However, the biggest changes of all are the structural ones. Although both engines are built on the same base, there have been several changes to their structure, such as a switch to stronger materials for the valves, cylinder head and head gaskets, as well as the camshafts and crankshaft. These changes were made to mitigate the reactivity that hydrogen is known for, and to increase the expected service life of the engine. As a result of these extensive modifications, both the 1.6 and 5.0 engines have maintained most of the performance levels of their gasoline-powered counterparts, while being equally fuel efficient. The 1.6 has been tested in a variety of different vehicles, including the Corolla GR, Corolla Cross, and most notably, the Toyota Yaris GR. The 5.0 is planned for testing in the Land Cruiser, as well as the Toyota Tundra and Sequoia at a later date. However, with great power comes great responsibility, and with great popularity comes a host of problems. So we must ask, are there any problems with using this technology? Yes, many problems have been identified. The biggest and by far the most prominent is obtaining hydrogen. It is indeed the most abundant element in the universe, yet it is rarely found alone. Hydrogen is mostly part of some compound, which means it requires processing before it is ready to be used in its pure form. While extracting it from water may seem straightforward, the truth is that it is quite complicated. The process requires electrolysis, which is a complicated and expensive process. Not to mention that it cannot be done just anywhere, as it requires specific conditions to be successful. As a result, obtaining hydrogen is, at least for now, a very expensive undertaking that is unlikely to be profitable. Driving a hydrogen car is currently 14 times more expensive than driving an electric vehicle, which is not something you want to hear when competing with electric vehicles. Not to mention that the electrolysis process requires electricity, which goes against the idea of replacing electric vehicles with something more environmentally friendly. Furthermore, even if you could obtain hydrogen in some other way, there is another problem: storage. Hydrogen is a highly reactive gas, and storing hydrogen is a highly delicate task that requires perfect conditions to be safe. This problem is even more serious when storing hydrogen in a car, as this requires reinforced tanks, made especially for this type of use. Since hydrogen is a highly corrosive gas that can, thanks to its structure, easily escape from any gap, hydrogen tanks need to be thicker so that they can resist the hydrogen and prevent it from seeping in. This significantly increases the weight of the vehicle, which reduces fuel efficiency and, in the end, increases costs. Therefore, many manufacturers are still avoiding investing heavily in hydrogen. But despite all the problems, Toyota has decided to go ahead with its plans. Furthermore, while access to refueling stations is noticeably better than it used to be in the 2000s, it is still far from being comprehensive and easy to use on a daily basis. There are only a few hydrogen refueling points worldwide, which makes the fuel unreliable for everyday use. Finally, as we have seen before, hydrogen is a highly volatile gas. Reactive, meaning that if it were to escape in any way, it could spontaneously combust, which could lead to fatal consequences. But while the situation for hydrogen may seem bleak when we focus on these potential problems, Toyota is convinced that it will quickly find solutions to them. How will Toyota deal with these challenges? Toyota has been relentless since it unveiled its first hydrogen combustion engine and has been working hard to find solutions to the problems we have mentioned. The first is the sourcing of hydrogen. Toyota is betting on the expansion of the use of hydrogen, not only in the automotive industry, but in all industrial and commercial sectors. This may sound overly optimistic, but there is indeed a rapid growth in the popularity of hydrogen in all its available forms. Shipbuilders are very excited about the switch to hydrogen combustion engines. Modern cities are slowly but surely starting to rely more on hydrogen, as are industries, which have started to use it as a real energy source. And as the use of hydrogen increases, the price of gas will decrease significantly over time. Of course, we are still a long way from hydrogen being truly affordable, but as its use increases, we can expect its price to drop exponentially. Of course, we can't expect hydrogen to be cheaper than electricity, but it will certainly be much cheaper than gasoline. Furthermore, when it comes to fuel economy, Toyota is doing its best to reduce consumption as much as possible, which would reduce operating costs even further. As for the tanks, if they are well looked after, they shouldn't cause any headaches. You just need to perform regular maintenance, like with any vehicle. Oh, and let's not forget the price. Unlike electric vehicles, which require a long development time to become usable in everyday life, hydrogen combustion engines are just a traditional mechanical device that is quick and cheap to make, making them ideal for mass production. However, even with everything we've seen in this video, there is another technology that Toyota is developing that could kickstart a new phase of hydrogen-powered cars. Toyota's new ammonia-powered engine. Recently, Toyota has begun exploring the possibility of using and storing hydrogen more safely by simply not separating it from the compound in which it is found. Their long and extensive research has led Toyota to consider the use of ammonia as a propellant. While water is the most obvious choice for obtaining hydrogen, extracting hydrogen from water is extremely difficult, at least at the moment. On the other hand, storing hydrogen in its pure form is also very problematic, as we have explained before. And this is exactly where ammonia comes in. Ammonia, which is a compound of nitrogen and hydrogen, serves as the best middle ground for further development of hydrogen-powered engines. This is because ammonia, unlike water, can combust, making it a truly viable fuel. Since ammonia becomes flammable under certain conditions and is rich in hydrogen, there is no need to separate the hydrogen from it. This eliminates one of the most complex parts of the process of using hydrogen as a propellant. Not to mention that by not splitting hydrogen, you also eliminate the need to store it as carefully, meaning another costly process of using hydrogen is completely eliminated from the equation. And you can also say goodbye to large heavy fuel tanks, as ammonia is much simpler to store than hydrogen. What's more, ammonia is also extremely abundant, as it is the most abundant alkaline gas in the atmosphere. This means that it is also exceptionally affordable to purchase, surpassing both gasoline and hydrogen in terms of affordability. On top of all this, ammonia is much more stable than hydrogen, which makes it safer. Unlike hydrogen, which is highly explosive, the only danger associated with ammonia is that it can be inhaled. The storage process is identical to that of LPG gas. Toyota is so excited about this idea that the company has partnered with Chinese auto giant GAC to manufacture its own ammonia-powered engine. Recently, the two companies announced the 2.0 i4 engine, which runs on liquid ammonia. After extensive testing, the engine has proven to be 10 times more environmentally friendly than its gasoline equivalent. Of course, this does not mean zero emissions. However, this is not the case for fully electric vehicles either, since both manufacturing batteries and generating electricity for them are extremely polluting processes. Furthermore, ammonia engines are technically hydrogen engines with only a few differences, most of which can be summed up in the fuel injection system. Its use will also allow for the parallel development of pure hydrogen as a propellant, making this a visionary and future-oriented technology. And when talking about the future, it is time to ask the most important question: is hydrogen the future? It is still too early to say, however. There are strong indications that hydrogen is on its way to being the fuel of the future. Despite the current difficulties, it is simply undeniable that hydrogen currently has the greatest potential of all other means of fueling vehicles. Despite its shortcomings, hydrogen remains the only way to fuel zero-emission vehicles, not to mention that it can also, with the development of the infrastructure and technology surrounding it, reach an incredibly low price. Furthermore, the electric vehicle industry has received a lot of backlash in recent years, as lithium-ion batteries continue to prove insufficient for real-world use, while also being extremely polluting and expensive to produce. As a result, even 10 years after becoming popular, electric cars are still an example of useless luxury, with exorbitant prescriptions and limited uses. This is exactly what hydrogen aims to fix. No one expects hydrogen to become mainstream anytime soon, but Toyota's insistence on developing it The remarkable growth of synthetic fuels in recent years, as well as the decline in popularity of electric vehicles, are factors that suggest that there is every reason to believe that hydrogen is far from becoming obsolete. One of the most ambitious projects in the world, Saudi Arabia's planned city, The Line, is also investing in the potential of hydrogen by choosing it as the main energy source for the entire city. And with the development of other hydrogen friendly technologies that are currently easier to use, such as ammonia powered engines, hydrogen's popularity will also passively increase, indirectly boosting its development in general. Despite the many problems it faces now, we can expect hydrogen to grow into one of the forces driving humanity in the next decade or two. That's it for today. If you liked it, don't forget to like and subscribe to the channel. Also, leave your opinion on the subject in the comments. We'd love to hear it. Thanks for watching and see you in the next video.